Hello guys, I'm Jose Alvaro from ECE 31. For today's vlog is about Experiment 6, Basic Arithmetic Logic Gates. The objective of this experiment is to familiarize the students with the nature of operation of basic arithmetic circuits and to stress the significance of logic gates in the internal capacity of computers. Here are the materials that we need for this experiment. Half-adder. For the half-adder circuit, we will be using the 7486 XOR gate and 7408 AND gate. We will be connecting the two resistors to the third pin of each IC, followed by the LED connected in series. Then, we will be connecting the first pin of the XOR gate to the first pin of the AND gate. The second pin of the 7486 XOR gate to the second pin of the 7408 AND gate. For input X is connected to the first pin of the XOR gate, and for input Y is connected to the second pin of the AND gate. Lastly, we put the connections to the ground. If both inputs are 0, the output will be off. Then, we place the input Y to 1, the output will be 1 and 0. If inputs are 1 and 0, the outputs are 1 and 0. If both inputs are 1, the output will be 0 and 1. And here are the results. Half subtractor. For the half subtractor, we will be using 7486 XOR gate, 7408 AND gate, and 7404 Hex Inverter Gate. The output of the 7486 IC is connected to the third pin, and the output of the 7408 IC is connected to the third pin. then followed by the LED, which is the outputs B and D. The first pin of the XOR gate is connected to the first pin of NOT gate. Then, the input X is connected in the first pin of XOR gate. The second pin of the XOR gate is connected to the second pin of the AND gate. Then, input Y is placed on the second pin of the exclusive OR gate. Then, we connect the second pin of NOT gate to the fourth pin of the AND gate. Then, we place proper connection of grounding of the circuit. If both inputs are 0, the outputs S and C will be off. Then, we place the input Y to 1, both LED will be on. If inputs are 1 and 0, the output will be 1 and 0. If both inputs are 1, both outputs will be off. And here are the results. Full adder. In this part of the experiment is the construction of the full adder circuit. We will be using the 7408 AND gate, 7486 exclusive OR gate, and 7432 OR gate. The full adder circuit has 3 inputs, which are X, Y, and Z. The 2 outputs are S and C. By following the circuit diagram in connecting to the proper pin configurations of IC and grounding, we are able to come up with the full adder circuit. If all of the inputs are 0, both outputs will be off. Then we place the input Z to 1, the output will be 1 and 0. If inputs are 0, 1, and 0, the output S will be on and C is off. For inputs 0, 1, and 1, the output will be 0 and 1. For inputs 1, 0, and 0, the output will be 1 and 0. If inputs are 1, 0, and 1, the output will be 0 and 1. If inputs X and Y is 1 and Z is 0, the output is 0 and 1. If all of inputs is 1, both inputs are on. And here are the results. Full subtractor. In this part of the experiment is the construction of the full subtractor circuit. We will be using the 7408 AND gate, 7486 exclusive OR gate, 7432 OR gate, and 7404 Hex Inverter Gate. The full subtractor circuit has 3 inputs and 2 outputs in it. The inputs are X, Y, and Z, while the outputs are D and B. Output D is for the difference output, and B is for the borrow output. By following the circuit diagram in connecting to the proper pin configurations, we are able to come up with the full subtractor circuit. If all of the inputs are 0, all outputs will be off. Then we place the input Z to 1, both outputs will be on. If inputs are 0, 1, and 0, both outputs will be on as well. For inputs 0, 1, and 1, the output will be 0 and 1. For inputs 1, 0, and 0, the output will be 1 and 0. If inputs are 1, 0, and 1, both outputs will be off. If inputs x and y is 1 and z is 0, both outputs will be off. If all of inputs is 1, both inputs are on. And here are the results. Summary of the experiment. Half-adder is a combinational arithmetic circuit that adds two numbers and produces a sum bit S and carry bit C as the output. Half-adder is the simplest of all adder circuits. The half subtractor is a digital circuit which processes the subtraction of two 1-bit numbers. The circuit of half subtractor consists of two inputs and two outputs. The output will be the difference and the borrow. Full adder is the adder which adds three inputs and produces two outputs. The output carry is designated as Cout and the normal output is designated as S, which is sum. Full subtractor is a combinational circuit that performs subtraction of two bits. One is minuend and other is subtrahend. Taking into account borrow of the previous adjacent lower minuend bit. This circuit has three inputs and two outputs. The two outputs, D and B out, represent the difference and output borrow. Here are some of the recommendations.